It was a Sunday morning, and like every other morning, I was just doom scrolling on my phone, and that's when I stumbled upon this video from the Primogen.
I just changed the way I program after doing it for 20 years. It's called negative space programming.
That's right, negative space programming. And by the way, I've never heard about this concept in the 5 years I've worked in the software industry. So this is something that's extremely new to me. And since I've also taken the responsibility of making sure that you learn whatever I learned, so I thought let's do a deep dive on this thing and let's see what's in store for us. Now, a simple Google search will tell you that it's a design paradigm focusing on defining what a program should not do rather than just what it should do. And for that, we can use assertions, constraints, and error handling to define invalid states. This approach increases software reliability, security, and clarity. Now, right off the bat, what I'm thinking is that isn't that what we should be doing as programmers? Like, isn't this common sense? So to clear out these confusions, I actually need to dive deeper. And so on the same page, there is a blog written by a person in 2010. So that's actually going to be legit, no AI. And with the way things are progressing, everything pre 2015 is actually golden. So it's a 4.5 paragraph long blog, and it's called Negative Space in Programming. I'm hoping this is going to give us insights on what negative space actually means. The author says that we all know how to write code, document it, build it, and test it, but considerably less attention is paid to what's not there. For example, the design alternatives that were rejected, the features that were omitted, and the tests that are no longer necessary because certain types of errors are made impossible by the design of a system. According to the author, this is a mistake. He goes on to say that the main way we actually give our programs shape is not by putting things in, but by leaving things out. An elegant program solves the problem it's meant to solve and does so concisely, and the quality of that program is not determined by what it's supposed to do, it's determined by what it does not do. In the last part, the author also mentions that refactoring code isn't straightforward at all. When you replace a line of code with another, you're bringing in assumptions surrounding it, like side effects that other pieces of code rely on and the problems that it doesn't need to deal with because they're avoided by design. The author also states that figuring out what the code doesn't do can also be positively enlightening when reading code. Huge shout out to Fabian for writing this article. I will leave a link to their profile in the description. So from what I understand, the author's definition of negative space is the set of assumptions that surrounds a requirement. And if we were to pay more attention to this negative space, we would eventually be able to write quality software. Now, I like this because it forces us to think more and code less. And by us, I mean developers. By the way, think more and code less is actually a superpower in an era where people usually think less and prompt more. Let's see how this translates when writing code. Now let's say the requirement was to write a feature to create an order. And with that requirement, what I would do is go ahead and create a function called createOrder with user ID, amount, and currency code as parameters. And then I would return an order. Now what negative space programming dictates is that we've just coded the positive space, and in order to address the negative space, we need to look at the assumptions that surround this positive space. So some of the assumptions made in this code is that the user ID that is going to be passed to this function is not going to be empty, and the amount can be anything. So we need to address these assumptions by coding them out. So here, we're going to say if user ID is empty, we're going to throw an exception. And same for the amount if it's less than 0. And that is basically how you code around the assumptions and make your program more stricter, and the quality of your software increases as a result. Now, what does it mean to write code for problems that are already avoided by design? Let's say I'm only looking at my createOrder function. And while thinking about negative space, I realized that I also need to add null checks in amount and user ID. Now, if I only look at this function, this is a valid assumption. But if I take a look at the call sites, it's only then that I will realize that making amount and user ID nullable is not exactly the way to go. Because here, by design, I've prevented user ID and amount to be non-nullable. And so, by making my parameters non-nullable, I've avoided writing code for problems that are already avoided by design. Let's take a look at another example. Let's say your backend API sends you this JSON object, in which username is populated, but you can also see that it can be null or any string can be passed to it. Now when you see this JSON object, you instantly create a front-end object that has username nullable. But the business requirements clearly state that when creating a username is a required field. Now the problem is when we try to use this front-end logic in other layers of the app, we quickly run into problems like these, where we have to map username to an invalid state just because it's nullable. In such a case, we need to assert that the auth contract will not be violated, and if it does, then we need to throw an exception. We also need to mark username as non-nullable and cater for these changes throughout our codebase. By doing this, we not only prevent invalid states to seep into our app, but we also made our program more elegant while addressing the root cause of the problem. An immediate benefit of this approach is that it helps you understand business requirements better. For example, if the reader reads through these lines of code, they will come to realize that there is in fact a backend contract that requires username to not be null. It also forces us to think more big picture. Does username need to be nullable, or if I check the usages of the model, it might be that username is by design negating that behavior. Now, while this makes our program more elegant, top quality, and robust, you're definitely going to get a lot of hate from the stakeholders because the program will throw an exception as soon as a problem occurs. This can also block important user flows. The positive of this is that you have identified a bug in the system, which we can easily fix now, rather than scrambling for it for hours because you made a certain field nullable and now you don't know where the issue is. Anyways, I think this is an elegant approach towards software development, and although I 100% agree with the concept, I think some of the things mentioned are just basic software engineering things. All in all, I learned a lot from this article, and I hope you learned along with me as well. Let me know in the comments what you think about negative space programming and this whole paradigm. As always, I will see you in the next one.